Hello and welcome to pH Physics. Today's explainer is specific heat capacity, the energy needed to heat 1 kilogram by 1 degree. By the end of this, you'll know the formula, water's surprisingly high value, and why we use it in radiators. Specific heat capacity, symbol small c, is the energy needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. The formula, delta E, equals mc times change in temperature, energy in joules, mass in kilograms, C in joules per kilogram per degree Celsius, change in temperature in degrees Celsius. Three things. 1. Every substance has its own C. Water is 4,200 joules per kilogram degree C, very high. 2. A high C means it can absorb lots of energy without warming up much. It's useful as a coolant. 3. Metals have a low C. They heat up and cool down quickly. Common slip. Confusing specific heat capacity with specific latent heat. Specific heat capacity is for warming within a state. Latent heat is for changing state without changing temperature. Quick example. Heat 2 kilograms of water by 30 degrees. The energy equals mc times delta theta equals 2 times 4,200 times 30 equals 252,000 joules or 252 kilojoules. The same temperature rise for 2 kilograms of aluminium, where C is 900, needs only 54,000 joules, less than a quarter as much. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus mastery workbooks across maths, physics, biology and chemistry. One for every higher topic, every answer fully worked, every common slip flagged for each subject. Simple explanations, serious results. See you next video.